So this will be a review for a heat pump hot water heater technology. It's not designed to actually review the GeoSpring. That just happens to be the one I bought. The first edition, it wasn't that great. They had some material issues. I had to return it. And I got the second edition or second generation of GeoSpring. That's worked perfectly, had no problems, but unfortunately the bad press and bad reviews that it got, I think, forced GE to discontinue it. But the second version, or the second edition, it's worked great. And so I want to review just the technology behind the heat pump hot water heater. There's other models out there. There's Rheem and a bunch of others, and they work on the same principle or the same technology as the GeoSpring. So I don't want people to get wrapped up in that. Anyway, so here's a review. Now this is my old school natural gas water heater. This was about 21 years old. It's really super inefficient. Again, I'll kind of go over the inputs and the outputs here. It's basically your cold and hot water taps here, and then the natural gas gets exhausted from the top into some kind of ducting system. The new ones, the ones that are higher efficiency, don't have this. They have like PVC or something like that because the temperatures are real low and they're super efficient, so they don't need to exhaust all those hot gases. And then basically you have a natural gas line that comes in and feeds the system here using some kind of a archaic control valve, and also you have a pilot light that is kind of resident in here, and that pilot light stays lit 24/7, which also burns gas, which also makes it super inefficient. So if you look at the numbers here, that's the energy guide. If you notice, this correlates to 277 therms per year, and that if you convert that to kilowatt hours, which we'll do later, that's pretty freaking high. 277 therms is, astronomically high. And actually it says the highest you can use is, at least in the class back in 2000, was 288, and this is 277, so this is hugely inefficient. So anyway, that's why I replaced it. They had a federal rebate that was, I think, $300 or $500, and then a utility rebate, which was another $300 to $500. So basically I used those two rebates, and I figured, well, it's already basically being paid for, and I'd pay, I don't know, $200 or $300 out of pocket, and I'll make that up real quick in return on investment. Okay, one of the things I didn't like about gas is I only use about $5 worth of gas in the summer, and I was charged $25 in distribution costs and all that nonsense, and the gas company makes all this money off of it. And so here's my my output for the last year of 2012. On the left hand side is the cost that I'm paying for the gas. Again, I excluded January, February, and December because those months I'm actually using gas to heat the house, so I just wanted to focus on what's the cost to run the hot water heater. So the next column to the right is what the electric kilowatt hour equivalent would be of therms, and so basically the 4130 is how much energy in kilowatt hours that gas would. So the columns in red are what it actually cost me to run the hot water heater. I use about $5 in gas, and everything else is fees and distribution costs from the gas company. And so I wanted to average those values out and see what it costs per month to do that. I excluded the other months because I'm actually using natural gas to heat the house, and so that would kind of skew the results. So it's about $30 a month just to use the gas. So when you average it out just to use the gas for the hot water heater, it's about $30 a month, which is $360 a year. So this is the heat pump hot water heater. It takes about 14 kilowatt hours, which is about 51 therms of gas if you were to convert it back and forth. And the gas is 277 therms, or 8,000 kilowatt hours. So there's a huge difference. So similar to a natural gas hot water heater, you'll have a cold supply line that comes down and goes into the cold part of the water heater, and then also you'll have a hot that goes out. And the only difference between a natural gas and an electric heat pump water heater is you've got AC that comes in. In my case, this is roughly 10 gauge wire, even though I don't use the electric on demand function. I use the heat pump 99.9% of the time. And also you have an air inlet. In this case, I've got, you can kind of see here, I need to fix this up, but I've got this ducted upstairs. So what it does, it pulls the hot air into the heat pump here and then basically stores it inside the unit. So you got hot air coming in, and then you have some type of cold exhaust coming out. Okay, in this case I've got my ducted system that kind of comes up here and pulls hot air from my living room into the heat pump. So I'm cooling my living room as well as kind of air conditioning the basement. So I got roughly 86 degree air going into the heat pump. Alright, so here's the back side of the heat pump. Here's the outlet that I'm talking about. The inlet was roughly 86 degrees, and this is blowing, let's see if you can see it here, about 38 some odd degrees of cold air. So this is actually air conditioning my basement. So I'm taking the hot air from the living room. I got a duct kit here that sucks in the hot air and then uses that hot air from the living room as a mechanism to cool the living space. It's just kind of second result of that, and also stores that hot energy, or the air converted into heat, into the tank. So it stores it in the tank here. So like a traditional water heater, you're going to have your two hot and cold lines coming in, and then the electricity here. So basically it functions just the same as a old school natural gas heater, except for it's a ton more efficient. And so, like I said, you have to worry about space heating. If you're going to put this in your garage, it's great, but if you're going to put this in your living room for whatever reason, and this is going to blow cold air out, you don't want that. But if it's in a basement and you got enough room, who cares if the basement gets cold unless it's a living space. But basically, this is kind of the setup. And then you also have a condensate drain here that will release the condensate. So when you take in hot air that's moist and you cool it, it'll create condensation. And so basically that's the condensate line. So like I said before, I've got a ducting kit. Normally you won't have this on a water heater. It'll just suck the ambient air in and store that. And I went a little bit overboard here. I got foil tape that's sealing all the little nooks and crannies to keep any hot air from leaking out through convection. But basically most all the hot water heaters will function the same. You'll have some kind of a menu. In this case, there's 4 different options, or 3 different options you can choose from here. You have heat pump, which 99% of the time I'll use. There's a hybrid, there's a high demand, and then there's an electric mode. These two will use the most amount of energy. This uses the least. So in the summer, I think I pull somewhere between 1 kilowatt a day to heat water, and that amounts to somewhere between, I don't know, $3 and $4 a month to heat all my hot water for the living spaces. And so that's a huge reduction from $30 to $35 a month down to $3. And again, the winter, maybe it might go up to 4 or 5, somewhere in there. But basically the whole crux of this is you're going to save a boatload of money. So over roughly the 7 years that I had this heat pump, I've saved somewhere on the order of $2,500 to $3,000 in cost versus having a natural gas inefficient furnace. So like I said, most heat pumps will have a similar type of interface. You can go in here and change your temperatures and go up and down and whatnot, but basically that's it. That's how most all heat pumps will function. They'll pull out the hot air out of the room, and then they'll exhaust cold air, and taking that energy out of the hot air they store into the hot water tank here. So this is kind of my setup. The other thing I also like to note is it's always good here to put some people will have a condensate pan, or in case something happens, a kind of a drain pan. But since my house drain here is real close and I've kind of got a downward slope, anything that will leak will go in here. But anyway, so I also put in about an inch of foam underneath the hot water heater so I don't conduct energy or heat from the hot water heater into the ground. And I also put a blanket on this, which I'll show you guys later. So that's basically the setup. If you have a electric tap that you can get into, and you can put a heat pump hot water heater in, I definitely recommend it. So these are the results of the cooling. I have a 500 square foot part of the basement where I have the heat pump in. So in the winter time, my basement's usually about 64 degrees, and when I kick the heat pump on, I usually get about 4 degrees of cooling, so it drops it down to 59. And then in the summer, I get about 1 degree of cooling, but again, I'm pulling the hot air from another room. Now my 50-gallon tank supports 4 showers every day and running the dishwasher, and then on the weekends usually we do laundry. I also have the temperature of the hot water heater set to about 120 degrees, so the higher you set the temperature, the more you use it, obviously your costs will go up accordingly. Okay, this is the cost and usage for the last 2 years. October 20th had a little hiccup in the system, so that value isn't right, but most of my costs are between $3 and $5 a month just to use the hot water, which is stupid low. And here's a snippet from my daily usage from my energy system. Again, between 0.6 and 1 kilowatt of energy, really, really low. Now, using a heat pump, it does take some time to recover the heat from the air and put it in the tank, and in the summer it takes about 2.5 to 2 hours. In the winter it takes usually between 4 and 5 hours to get 120 degree water when you're recovering the heat from the air. So this is the return on investment for my hot water heater. You can usually find hot water heaters on sale at Lowe's or Home Depot. In my case, I found one that was $1,000. I had a $300 federal tax credit and then a utility credit of $500. So out of pocket, it cost me about $200. If you look at the before and after savings versus using gas, I save about $300 a year, and that's about a 0.6 return on investment for the hot water heater. Okay, those are results from my heat pump. Please like and subscribe, and let me know in the comments below if you had a heat pump and it's worked great, what your savings are, and if you had a heat pump and it didn't work so great, what happened. I like to hear what other users have experienced with their system.